so today we are talking about exponential growth and exponential decay. And guys, our exponential growth and our exponential decay functions have, basically we are starting with the same exact form that we started with with exponential functions. F of x equals a times b to the x. But guys, growth happens when your b value is greater than 1. And decay happens when your b value is smaller than 1 and greater than 0. Okay, guys? So growth is when your b value is greater than 1, and decay happens when your b value is less than 1. Page 4. Okay? So here we are. So guys, we're going to be looking at these first. We're going to look at these first 4 functions before we talk about anything else. I want us to identify, is this growth or decay? So Travis, I want you to help me out. Y equals 15 times 0.9 to the x, 0.98 to the x. Is that growth or decay? Okay, what are you looking at to tell you that's decay? 0.98. Perfect. We know that's decay. What is the 15, Travis? Y'all remember? What's that 15? You want to help him out, Sasha? It's the a value, and the a value represents our y-intercept, okay? Now, guys, the y-intercept didn't control the growth or decay. The 0.98 is that growth or decay factor. Okay, let's go right here. Eric, 1.75. Is that going to be growth or is that going to be decay?
Growth.
Growth. Why is that, sir?
Because it is above 1.
It is greater than 1. Fantastic. All right, let's look here. Miss Sophia, 0.75. Growth or decay? Decay. Why is that? It's less than 1. It is that simple, y'all. So, Jude, help me out. 0.57. Is that going to be growth or decay?
Decay.
Decay. Why is it decay?
Because it doesn't have a number or point.
Yeah, it's less than 1, right? It could be 0.57. You could see it as 0.57, 0.57. Okay? So, guys, that first things first, always look at an equation and say, is that growth or decay? Because that is going to help you either eliminate some options and some answers. Now, guys, here's the deal. When you have decay, you are always decreasing. Okay? If you have growth, you are increasing. So I'm going to go ahead and match those correctly. Growth is an increase. Decay is a decrease. Okay? Now, what we want to talk about is this 0.98 is the decay factor. But we want to know how much percent decay is actually happening. So guys, your B value is the decay factor. But if we want to know the percent decay, what we have to do is we have to convert this essentially to a percentage. Okay? So what I'm going to do is I'm going to take this 0.98 and I'm going to subtract it from 1. Because 1 is like 100%, okay? So I'm going to subtract it from 1. So I'm going to say 1 minus 0.98. And that gives me 0.02. Are you guys comfortable with that? Okay. So when I do that, that gives me 0.02. What percent would that be? 0.02 would be, we'd move the decimal point 2 places, so it would be a 2% decrease. So guys, you can think about this a couple different ways. This 0.98 is kind of like 98%, right? So how much below 100 is that? 2%, okay? So you can subtract it from 1 and then convert your decimals. Now for this one, it's going to be a little bit different because we're not at a decrease, now we're at an increase. So I want to know how much over 100% is this. So I personally think that the growth is easier. So Yusuf, this time my 1.75 is over the 1. So I'm going to do 1.75 minus 1. So what is my percentage away? How much did I increase? 75%. Because we can go ahead, if we move those decimal points 2 points, we get a 75% increase. I personally think that the growth is a little bit easier to recognize because it's just the number after the 1. Does that make sense? That 0.75. You're like, oh, it's a 75% growth because it's going up that much. This one is the one that I have to do, like I have to do the math for, okay? And I think, okay, how far away from 100 is that? Well, 1 minus 0.98 gives me 0.02. So that's a 2% decrease. So we're going to do a couple more decays because I think those are harder. So, guys, this 0.75, Jacob, go for it. Okay, what would we do? So if we do 1 minus 0.75, what does that give me? That gives me 0.25, because that's a whole number. 1 minus 0.75 gives me 0.25. So guys, what percent decrease was that? 25% decrease. Does that make sense, y'all? Yes, no, maybe so? Okay, now we're going to look at this 0.57. That's a decay, so we want to know how far away from 1 is that. So I'm going to say 1 minus 0.57, and that gives me 0.43. So guys, that is a 43% decrease. Does that make sense, y'all? So this is going to be really important because, guys, sometimes you're going to be asked for the decay factor, and sometimes you're going to be asked for the percentage, the rate decrease. The decay factor is 0.75, but the rate that it decreased at was 25%. The decay factor is 0.57, but the rate that it decreased at was 43%. Does that make sense? Because that's the amount of way. So guys, sometimes you will be given your formula, and sometimes you have to find your formula. So guys, for this one, you're going to have 2 exactly like this on your homework. And guys, we are given our equation right here where it says f of x is equal to a times b to the x, where a is equal to 0 and b can't equal 1. So guys, let's look at this. A is going to be my initial value, or the y-intercept, right? So that initial value or the y-intercept. And guys, your b, this right here, remember this is the growth or decay factor. And guys, in order to find our b, you can take y2 and divide it by y1. Just like y'all did on Friday, where we did y2 divided by y1. Okay? So guys, let's take a look at this. Researchers studied the population of a town over time. Okay, I'm going to zoom out here. And modeled it using an exponential function. So they told you it was exponential. The initial population was 48,000. Ooh, 48,000. So guys, if that's my initial population, what letter is 48,000 going to represent? A. So we have our A value right there, 48,000. The first year, the population in the town was 50,400. So guys, if it continues to grow at this rate, what function can be used to model the population in X years after the researchers began their study? So guys, when I get my B value, should my B value be above 1 or less than 1? Why should it be above 1? Paula, why do you think it's going to be above 1? Why would my B value be above 1 here? Go for it, Delmar.
Because the number's increasing.
Because the number's increasing. Because my population is growing. It's got growth. So this is exponential growth. So guys, right away, we know my B value has to be greater than 1. So in order for us to find our B value, we have to do that y2 over y1. So guys, that y2 over y1 would be 50,400 divided by 48,000, right? So guys, if we do 50,400 divided by 48,000, my bad, we get 1.05. So guys, that means that this right here is my growth factor. All right, guys? So that is my growth factor. That is what it is growing by. And guys, you can write it as a fraction right here, or you can write it as the decimal. Either way, okay? So that's your growth factor. So then if I'm going to write my equation, I would write it as y equals 48,000 times, let's do it as the fraction first, 50,400 over 48,000, and then do to the x power, or you can also write y equals 48,000 times 1.05 to the x. Okay, guys? And when you're writing the equation, don't forget the x exponent. All right, guys? If you forget the x exponent, it's going to be wrong. So don't forget your x in the exponent. Exponential functions have x in your exponent. All right, guys? So, guys, after all that, we just found our growth factor. So now, what is my rate of growth, guys? We know that we're dealing with growth here. So that rate, guys, is a percentage. So what's my rate of growth? How do we find that rate of growth? Well, guys, what's my growth factor? David, go for it. So 1.05, and then what do we need to do to find that rate? Subtract 1. So that becomes 0.05, which means that we have a rate of growth of 5%. Does that make sense? If I was asking for the B value, that's 1.05. If I was asking for the rate of growth, that's 5%. They're different, but they're also kind of the same. Does that make sense, guys? They're connected to each other, but they're different asks, okay? So let's take a look here. We only got about 5 more problems, and then you guys will get to work on your homework today. Okay, let's look at this guy here. It says the function w of t equals 270 times 1.09 to the t, raised to the t, can be used to estimate the number of whales in the North Atlantic Ocean at the end of t years. Identify all the attributes. So guys, they gave us the equation. We don't have to find it. So in this particular situation, 270, Yusuf, what does this 270 represent? Is that my A value or my B value? Okay, so my A value is 270. And what does that A actually represent? What does that mean? Go for it, Marcella. It's the y-intercept, but what does it mean in this situation? What is the y-intercept? We're talking about whales. So what's it going to be? It's an initial amount. David, go for it. Yeah, it's the initial whale population. Okay? So our initial whale population was 270. Okay? Now what's happening to my whales? Looking at this B value right here. Guys, are my whales, is the population increasing or decreasing, JC? It's increasing, it's growing. So if my B value is 1.09, that B represents the growth factor of the whales, right? So guys, each year we multiply the number of whales by 1.09, 1.09, 1.09. We multiply it by that 1.09 to get our next growth of whales here. And so guys, if the growth factor is 1.09, what is the rate of growth right here? We subtract the 1, so you're exactly right. It's going to be 9%. So guys, my growth factor was 9, and so that means that that rate of growth is 9%. Now guys, one thing that I want to show you is sometimes they will write the equation like this, okay? they will write it as 270, and then instead of saying 1.09, they would say 1 plus 0.09t. They would have it separated, okay, 1 plus your rate. That is very common. You can see it as 1.09 or 1 plus 0.09. Does that make sense, guys? You can see it both ways. And so I've seen it on multiple choice problems, both things. But guys, 1 plus 0.09 and 1.09, they're exactly equivalent to one another. Okay? Let's take a look at this guy right here. A bank account earning an annual compound interest was opened with no additional deposits or withdrawals were made after the initial deposit. Okay? So guys, real quick, before we move on, if a bank account is earning money, is that going to be growth or decay? Growth. There we go. Praise the Lord. All right. So here we go. So we're doing growth. Now, the balance in the account can be modeled like this. E of x is equal to 850 times 1.025 to the x. Identify all key attributes. So guys, what is my A value for this little function right here? The 850. And what does that actually mean? We know it's our y-intercept. Yeah, go for it, Jacob. It's the initial deposit. Exactly right. It's the initial amount of money we have. So guys, that A value is that initial deposit. And guys, if we graphed it, it would be the y-intercept, okay? But it would be this initial deposit. My B value is that 1.025. And this represents my, go for it, growth factor. So guys, this is the growth factor of the money, right? So every year we're growing our money, okay? And so our rate of growth, this one's a little interesting. We would say 1.025, there we go, try again. 1.025 minus 1. And that gives us that 0.025. Now guys, use your calculator. There's zero shame in that. 1.025 minus 1, and that gives me 0.025. Now this one's a little interesting. If I move my decimal points on this, guys, what's my percentage? What is it? Is it 25%? It is 2.5%. So wait, you're telling me I can have decimal points in my percentages? Yes, you can, okay? Do not get confused about that. You can have decimal points in your percentages. So it is a rate of growth by 2.5%, okay? Now, oftentimes, guys, what happens is we will use these equations and we'll say, okay, if this is your equation, how much money will you have in 10 years? So what we would do is we would say times 850 times 1.025 raised to the 10th power. And when I do that, so after 10 years, just putting money in there and not touching it, you would have $1,088.07. All right? Does that make sense? Just putting it in there, putting it away, and not touching it, you get a couple $100. Does that make sense? So hopefully, the trick with earning money, guys, with investments, is you don't just put an investment in one time. You, continue to invest, because then it continues to grow more and more and more. But even if you just put it in there once, you can just let it grow. Okay? So does that make sense, y'all? Does this kind of track a little bit? You guys okay with this? Okay. Let's look at this one right here. I like this one because it's a multiple choice. This year, the number of students who participated in sports, and just sports, all sports, was 317. Okay, that is not true for our school, but this must be a much smaller school. So our number is much higher. So 317. Each year, the number of students who can participate in sports increases by 4%. So guys, is this going to be a growth or decay situation? Growth. So we know that we have to do this. Okay, and that our number is going to have to be bigger than 1. Which function can be used to model the number of students participating in sports after X number of years? Well, guys, if we're dealing with percentages, we are dealing with exponentials. So are there any problems that are just trash and that you can just throw away?
Yes.
Okay, which one would you throw away, Eric?
The 4 plus the 4x plus 3, 17.
Yeah, this is linear, isn't it? That's a linear graph, y'all. If you graph that, that would be a straight O line. So that's no good. Is there any other one that we can kind of toss out here? Go for it, Eric. D. This one is also linear. So guys, those are not, that's not the right kind of model of relationship we're looking for. When you're talking about percentages here, it's going to look a little bit different. So that leaves us with A and C, y'all. Both of them have the correct A value, don't they? But which one, let's see here, guys. So we know that my A is equal to 317. And guys, my rate of growth is 4%, or 0.04. So guys, the rate of growth, is that going to be represented better by A or C? C, because guys, we are saying 1 plus the 0.04 to give us the 1.04. So guys, my B value is going to helps us see that it's C. Now guys, A is growth, but that's just like 400%. That's like a huge, or 300% growth. That's huge, huge, huge growth. That's a 300% growth. Now guys, one thing I want to remind you of is sometimes you'll see it as 1.04. Sometimes you might see it with that 1 plus 0.04 as it's separated out. Okay guys? You might see it that way with the 1 plus or the 1 minus. Okay? Let's look at this guy. An insect population after X months can be modeled. Oh gosh, I hope all the mosquitoes just died. Okay, that's my prayer over these last couple days. So, get them out. All right, but let's see here. I hope that we are in a decay situation with our mosquitoes right now. But we are at this function g of x is equal to 18 times 1.3 to the x. Identify all key attributes. So James, help me out. What is my, oh, you're already doing that. Okay, let's go over here. Jacob, go for it. What is my A value? Yep. Your initial insect population. All right, guys? So it's your initial insect population right there. And then what is my B value, Harrison? Perfect. So that's going to be 1.3. Yeah, so we basically are taking those insects and we're multiplying them by 1.3 every single year. But guys, that rate is the, why did I do that? The rate is the percentage, okay? I don't know why I wrote an 8. I just was mixing them up. So guys, that 8 is the rate is a percentage of growth. And so guys, we're going to say 1.3 minus 1. So that gives me 0.3. So y'all, that's a 30% growth. That's disgusting, the number of insects that grow, okay? That's a very large growth. Blech. All right, they are increasing by 30%. I don't know if that's daily. Oh, months. Okay, every month. That's fine. I'll take that. All right, y'all feel good about that? Okay, so guys, that's a 30% of growth. We have one more we're going to do together today. Yes, ma'am. So yeah, so if you're starting with your, that's a good question. So Haley asks, do you always move it twice? Yes. Okay. So for example, if I gave you one that was talking about, let's do a decay one really quick, and I said, okay, if we had y equals, I don't know, 300, we're going to start with population of something, and it's going to be 1, oh, it's not going to be 1, it's going to be 0.87 to the x. So if we have something like this, first of all, our initial value is that 300, right? And then our decay factor is 0.87, right? So if I was doing one like this, and I asked for what is the rate of decay, then what I would do is I would say 1 minus 0.87, and I would get 0.13. So that would be a 13% decay. So after you subtract it, Haley, then you move your 3. Okay? Now here's the thing. What I have also seen is I have also seen it written like this, where you could say y equals 301 minus 0.13. Does that make sense? So I've seen it the other way, Haley, where they give you the 13% decay. They say, oh, this is decreasing by 13%. So you have to move the decimal back to the left and subtract it from the 1. Does that make sense? Because it's decaying. Up here, we were adding it to the 1. Here, we're subtracting it from the 1. Okay? Does that help a little bit, guys? Yes? No? That one's decay. I like this one. We have a lot of growth one on our notes, but you will get some decay. All right, last one. This is it. All right. The initial value of a home is $200,000. The value of the home will increase at a rate of 6% each year. So, guys, if it's increasing, is that going to be growth or decay? Growth. So that means my B value better be bigger than 1. Which graph models this situation? So, guys, if my A value is 200,000, what does that represent on a graph? The y-intercept. So, guys, because we know that's the y-intercept, which ones are absolute garbage and trash? G and J. They have the wrong y-intercept. This one has the wrong y-intercept. So, guys, please use your brains and use your common sense. That eliminated half of your options. Those have the wrong y-intercept. Okay, guys? So now we're just left with F and H. Okay? And so now we have to think about our B value. Well, guys, if it is growing at 6%, that is really the same thing as 0.06. Are you guys comfortable with that? 6%. We're going to move our decimal point the two places to the left, and we are at 6%. So if it's growth, then we have to add the 6%, or the 0.06, to get me 1.06. So guys, my B value is 1.06. You guys comfortable with that? Because we're adding it. It's greater than 1. Guys, if this was decay, we would have subtracted the 6%. But because it's growth, we're adding the 6%. So now my equation is y equals 200,000 times 1.06 raised to the x power. Now here's the thing, guys. Both F and H, do those both look like growth? They do. This one is extremely rapid growth, and this one isn't quite as rapid. So guys, what's a way that we could actually find out which one is correct here? Yeah, I would use the calculator. Guys, we know that this point is 0, 200,000. We know this is 0, 200,000. Guys, are there any other like clean, good-looking points here? Not really. So what I would do, personally, is I would plug in y equals, let's see here, y equals 200,000 times 1.06 raised to the x power. Now guys, will I see that on this little graph on the calculator right here? No, because it's 200,000 is our y-intercept. It's way, way up there. So what can I do on the calculator? That was a weird way to say it. On the calculator, if the graph can't help me, what could possibly help me on the calculator? The table. So we're going to jump to our table here. And we know that it should be, if we have our x and our y, we know it should be 0, 200,000. Oop, not 2 million, 200,000. Now, guys, what are my x's going up by each time? 5. So I'm not going to mess with the 1. I'm going to jump here to 5. So at 5, my equation should have 267,645. At 10, my equation should have 358,170. Now, guys, when we see this, which one of these graphs is going to match those table values better? F or H? Let's see here. At 5. Guys, does that look like that's about 267,000 right there? That looks pretty good, right? Okay, guys, look at this. Guys, does my 5 even touch anywhere right here? No, it's like over 1 million. That's crazy. All right, guys? So this one is also wrong because this guy matches our table. So this one matches the table. All right? So does that make sense, guys? Y'all feel good about that? So, guys, honestly, using your calculator, using your resources, using your common sense, is it growth, is it decay? All of those things are going to help you guys do this today. Okay? So now we're going to go ahead, we're going to get out our homework, and we are going to get ready to get started.